trigonometry, and it's available in Richard James Mathematics Resources. Now, trigonometry. Some people call it trigonometry because you imagine that it is very difficult. And this topic is one of this topic is, yeah, you can have, this topic is one of the simplest topic that you can imagine. Trigonometry. As some people say, trigonometry. Now, what is the foundation of trigonometry? Trigonometry is based on, right, but it has its foundation in similar triangles. And what we mean by similar triangles, if you consider similar triangles, then corresponding angles will be the same. This will be y, and this one will be y. No, that's z. This one you may call it that. But as long as the triangles are similar, then corresponding angles are equal. And you know that if you have two angles of a triangle, then the other angle is automatically known. So we don't have to consider the other angle. As long as we have two pairs of angles that are the same, then we do not have to consider the other one. We are sure that we have similar triangles. And what is it about similar triangles? For similar triangles, the sides are in a particular ratio. Say this one is 5 units. This one is 13 units. And this one is 12 units. Maybe this is half of 5, so this would be 2.5. This one will be 6.5. Right, 6.5. And then this one will be 6. Right, so this is the background of trigonometry. For similar triangles, the ratio of the sides. The ratios, you put the sides in ratios, then all of the ratios will be what? Equal. Right, so what we'll have is, if we say for the corresponding side, 5 divided by 2.5, that will be equal to what? 13 divided by 6.5. And that is going to be equal to 12 by 6. And what is 12 divided by 6? 2. And what is 5 divided by 2.5? Well, 2.5 is half of 5. So it should be 2. Right. And 30 divided by 6.5, that will be 2. And this is how trigonometry was developed. It is only that we have it for our right angle triangle. So we consider right angle triangle. And before the end of the day, we will realize that trigonometry is not limited to right angle triangles alone. So let's say this angle is 30 degrees. And then let's say we have another triangle here. This one is larger. It's a right angle triangle nonetheless, and let's say this angle is 30 degrees. If we have sides, say A, B, C, and we have sides here. You give me the name of these sides. D, so D, E, F. Now, although we are not so deep into the trig ratios as yet, because we're going to go into that in a short while, the sine of this angle, is what? degrees, of course, there are degrees. I hope I have degrees in that, and that's equal to 0.5. Yeah, someone is saying that I should use opposite and hypotenuse. Yes, because in this particular triangle, this is the opposite, this is opposite, and this is the hypotenuse that we'll look into in a short while. But what we're looking at the moment is how the entire thing about trigonometry was developed. And it was developed on the premise that the ratios of the sides of similar triangles, those ratios are equal. So the ratio of this side to this side is equal to the ratio of this side to this side, as long as the angles are the same. And that is why we can make calculations in trigonometry, because the ratios of corresponding sides of similar triangles are the same. So we have that is equal to 0.5, and that is going to be true for this triangle and also this triangle. Now we're going to take a look at the fundamentals of trigonometry and then see where we begin in this instructional manual. Right, for this instructional manual, we look at the ratios of corresponding sides of similar triangles, because that's the foundation of trigonometry. And some people say, why aren't we looking at the opposite, the adjacent, the hypotenuse? Why we are not looking at that? Because those are consequences of making use of the fact that the ratios of sides of similar triangles are equal. I hope everybody is looking in his or her instructional manual at the moment. For the similar ones that we have inside of the instructional manuals, I'm going to put those on the board. So we have two similar triangles. I think I'm going to put one of them somewhat here. That's one of them. And this is the other one. I'll put a little bit down with that. So we're saying that those triangles are similar. So we say A, B, and C. We also say, you have that in your book. X, Y, right. And of course we do this. Without putting any number here. And we do this without putting any number, giving you an idea of the corresponding angles that are equal. If we don't have corresponding angles that are equal, then we will not have any such thing as similar triangles. So these triangles are similar because they have what? Corresponding angles are equal. And although these are not right angle triangle and these are not formal trigonometrical ratios, we can write some ratios right here. So give me in the form of a fraction, one ratio.
A over C equal X over C.
So we have A over C. So we have A over C, and that will be equal to what?
X over C.
Right, X over Z. And old people like me say Z, but it is your same Z.
So B over C equals.
Alright, so we say B over C. What's that equal to?
Y over Z.
Okay. Y over Z.
A over B.
A over B equals, let me see, A over B is equal to X over Y. And that is true for your similar triangles. Do we have anybody volunteering in class? established for your trig ratios is that your trig ratios are defined on what kind of triangles? They are defined on right-angled triangles. And I have a serious problem with the usage of terms in mathematics. Some people do that do not fit into everyday life. No. For your right angle triangle. In your right angle triangle, what is the longest side called? The longest side is called the hypotenuse that we call H. And how do you know the longest side of a right angle triangle, apart from the fact that it looks longer? It is opposite to the right angle. So it is opposite to the right angle. The hypotenuse is opposite to the right angle. What do you mean by opposite? Facing the right angle. And usually, to be opposite, you should really be on the other side of. So you are facing or opposite, that should mean the same thing. Just as if you are going downtown. And you know that there's a popular place downtown that they have a business place. And in a fire it was burned down, right? You don't know that? You all don't know that? No man, they call it burned down. Right, in Montego Bay. You have a place that they call it burned down. So if you want to identify a place, you can say it is opposite to burned down. Go and find MK Mart. I'm not so sure that that's so. It's a Chinese shop. Right, the Chinese retail store.
They didn't be burned down.
No, it was burned down and then they had a fire and it was burned to the ground. So they just give it a popular name that everybody. Remember, sure none of those who know of that place. See? Right. Better be you know about it. What about MK Mart? Alright. Oh, you want to know where Bodong is? It is opposite to MK Mart. Is it? Right. It's on the other side of the road from it. Not exactly opposite. You're saying it's kind of still like a little bit to the side.
Wait. Oh yeah.
It is opposite, right? It is opposite to Henderson by which road? Because I'm using St. James Street.
I had to see that also.
No, it is beside it. This nigga looking at St. James Street. Which one? Bottom? MK Mart? What about MK Mart? MK Mart is beside Henderson.
Yeah, but it's across the road. Like, the road separated. Well,
MK Mart is at a burger. Burger King is at a fitness.
Oh, okay. That's good. Because you know that if it is beside Burger King, then you know that it also has its application here. So, the one that is facing, let's say this angle is theta, common Greek letter theta. The one that is facing this angle is said to be what? Opposite. Opposite, facing, on the other side of. What about the other one? What is adjacent? Beside or alongside. That means that Burger King is adjacent to MK Mart. And then Henderson is adjacent to Burger King. And that's in the church. Right. So which one is, oh, they changed the name of Parade Fashion?
Yes.
Okay. What?
So what's my
They have the original was called Parade Fashion. Yeah, Parade Fashion. Yeah. Right. So yeah, I know that it was changed to that as a matter of fact. So for your opposites and your adjacent, they have the same meaning in trigonometry that they would have in your everyday life. Opposite and adjacent. And you know that your hypotenuse is what? The longest side, and that is opposite to your right angle. Okay. So what I want you to do, well, as a matter of fact, let me put something up there that's somewhat skewed. It doesn't look so right to me about that. Yeah, right angle. So I'm going to put another angle inside here. Maybe I'm going to call this angle capital A. I'm going to put like X and your favorite Z. To A, which side is opposite?
Y?
Right, that's AC. Right. So in this case, we are saying Y is opposite to the angle A. So in this particular case, the opposite is Y. With respect to this angle A, which one is adjacent?
Z or X?
Oh, I like that answer. Which one is the hypotenuse?
X.
Very nice. I heard someone saying adjacent to the angle Z or X. Is that person correct or incorrect?
In a sense. Trigonometry, correct?
In a sense, it is correct. In a sense, it's correct. You said it, so what are you saying? People taking up for you and taking up for yourself?
Sir, I think it's adjacent.
Let me tell you. If you look at what adjacent means in trigonometry and real life, adjacent to this angle, we have X. And adjacent to this angle, we also have right. However, in trigonometry, we like to separate the hypotenuse as the longest side. So when we are speaking about the adjacent side, we don't generally talk about the hypotenuse. We are generally not referring to the hypotenuse. But if someone says the hypotenuse is adjacent to the angle, then the person is actually right. Because it is actually adjacent to the angle. Right? But in solving your problems, you will have to cause the hypotenuse to stand out as being separate from that side, from the other side. And also not referring to it as being adjacent, although it is. Which one? Right. And the hypotenuse is also the one that is across, which is opposite to the right angle. Yes. So that is something that you need to give consideration to. And you know, when things like these happen, you know what I remember? Pep, that is trying to get students to think out of the marks. Right? And to be able to substantiate your claim. Because according to you, the side X is also adjacent to the angle. And by the definition of adjacent, it actually is. Now, you have 3 triangles. And you are required to identify the sides relative to the angle that is supplied. For example, look at this situation. Well, it's the same thing. It's the same thing in your everyday life. If someone said identify the opposite side or opposite, identify the adjacent side, you should not really be able to do that unless you have something or some angle. In this particular case, it's an angle to say that it is opposite to that angle or it is adjacent. Because if you say it's B, suppose this is the angle that we're talking in hurricane stuff. So what do you say about that now? So if we're talking about R, is P opposite to it? Okay. So we have to say the opposite, the adjacent, relative to the angle that is given. And that is what we have right there. So you can start the exercise as a matter of fact, because you have it right in your instructional manual. And I will attempt to put them on the board for those who do not have your instructional manual. Well, all of you have them, but those who are watching might not necessarily have theirs. On page 2, so look on page 2 and you have 3 triangles right there. You have 3 triangles right there. Students, the reason for individuals finding trigonometry so tough is that they don't want to put in any information in their brains. They want to just imagine that they can just do trigonometry without having any information. 13 centimeters. 12 centimeters. 5 centimeters. 7 centimeters. 24. 25 centimeters. 'You need that, please? Now for this one, you just need to say the specified angle is an angle that is specified. You need to identify which one is opposite to that angle, which one is adjacent to that angle. And also, you need to be able to identify the hypotenuse. Come on, everybody must finish that piece of exercise already. Identifying relative to that specified angle. Decide that it's opposite, adjacent, and also identifying the hypotenuse. What are you writing so much, Mr. Because you like writing a lot of stuff down here. You don't have to try them over, just put. You don't have time to do that, because you have the angle, you have the drawing, you have the instructional manuals. So all you have to do is just say for this one, for A, relative to A, the opposite side is what? The adjacent side is what? And then we identify the hypotenuse as 13. Right, that's all I need to do. The number of triangles you need to draw. You have to draw 8. your tutorials. Students, pick up your tutorial one book. Because by the time we are through with this, we are going to be doing a lot of tutorials and tests. Yes. Yeah, tutorial one. I'm not saying by the time we are finished with this particular topic, no, by the time we are through with the trigonometry module, which is not going to be too hard. Ready for the next one? You are saying no, mister? What is opposite to, let's put it, we are looking at B. What's opposite to B? What's adjacent to it? And the hypotenuse is what? Irrespective of which angle you're talking in reference or you're speaking in reference to. 25 centimeters. And the angle we're talking about is this one, C? Is that the angle? Okay. Who is saying here? Alright. So I'm sure that you're finished with this. All you have to do is just write down O is equal to A and the hypotenuse is equal to. There is nothing else to it. You finish this one, mister? Don't wait, don't draw the triangle because I have it right there in your book. Just write down the O, the A, and the hypotenuse. Which one is opposite to this? Which one is adjacent? And which one is the hypotenuse? Finish? Remember, show and have those who are not finished with this yet. Alright, so we have what? The opposite is, one opposite to this is 4 centimeters. The adjacent one is 3 centimeters. And the hypotenuse is 5 centimeters. That's nice. Very nice. Now, anybody having any difficulty identifying the sides of a right angle triangle? Yes, relative to a particular angle. No. So now that you can do that, then you can take a look at the synthesis of the trig ratios. Use something local. Alright. For your trig ratio, we have sine, cosine, and tangent. Right. And we define sine as what? Sine is equal to opposite over hypotenuse. And cosine, well, we use the short version. Cos is equal to what? And tan. And I heard somebody inside here saying, so Katoa. When we were in school, it never did anything like that. No, we just know them. mnemonic still. And I am in favor of using mnemonics, yes. But we never use that.
So I was thinking of what's the mnemonic at the sir.
These are just a single word. For those who love soca. See, I don't even know how to write it.
No, sir. S-O-H.
See? S-O? O-H. Yes. C-A-H-T-O-A. Right, because I don't use it. We never use it in school at all. We just know them. Yeah, those were the when people were really into stuff. So
S-O.
S-O-H.
So that's how good mnemonic can be, sir.
Look like you love so kind of. I'm going to tell your mother. Is that a good one? You just have one so you to remember the activity series.
So how you must remember that, sir?
Okay.
Please.
This is for copper. This is for hydrogen. This is for lead. This is for iron. This is for zinc.
So physics.
No, chemistry, aluminum.
This is magnesium. This is calcium. This is sodium.
So that's how you pronounce that, sir. Sir, that couldn't say. I couldn't pronounce it.
We had a student in our class by the name of Krishna. And he said, Krishna never called my answer for 2000 centuries. My answer for 2000 centuries. Yeah. And you also have this about what? My very educated mother just sent us 9 parties.
My very educated mother just
serve us in a pot.
Or my very educated mother just showed us 9 buttons.
Okay. I hope you don't have any mnemonics like we did that you have to whisper.
I'm telling you, sir.
Anything that you have to whisper, you don't say it out loud, right?
Yeah, but we must do that.
What?
What?
We have a contents when we were in primary school. You remember that?
What, sir?
And then the universe. So you could write it in reverse also. Simply. Some teacher never hit till 9 o'clock. Contents. When we were in school to spell words. No, it's just like when we were in school, we were really into books. So the words we used to see this word a lot, like in grade 3 and 4 and so on. So we used to make mnemonics in order to say yes. Yes. And every night, ganja light in Shira house. Yes. Every night, ganja light in the Shira house. Right, so you see, use a lot of stuff to cause us to remember stuff. Those were days when people used to study. So that's why I decided to develop mathematics resources.
In the 90s, sir?
No, 1996. A lot of stuff in the street when you're walking home, all different kind of crazy things. And I did not have a cell phone until 5 years later. So you can imagine now that you have a smartphone and all of these things, that you are so distracted that you can't even breathe. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Right, so we'll put another 3 triangles up there, and you're going to write down sine of the specified angle. Not so steep. About that. So that can have a right angle there. You remember? Every good boy deserves favor. There's another one. And you know that they change it and kind of make it so different. It does not play well on the internet. This is other proportion. B. This one is what? A. I'm going to put C. C is your regular right angle triangle.
So something already was.
Remember that it's going to be delayed a bit.
Yes.
This one is what? A. 50 centimeters. Look at those. So all we're going to do is, for example, which one is A? The first one. So we have what? Sine of A, and you just put the what? Which one is opposite? Hypotenuse. See, sine is opposite over hypotenuse, so that will be what? I heard somebody saying 50. Let's clarify that. The hypotenuse is the longest side internally. You'll see that because of the number. And you will also see opposite to the right angle. Yes. Alright, no problem. What about cosine of A? Actually, you're going to take a look at the adjacent. Adjacent over hypotenuse. And that will be 15 over 17. And then the tangent is what? And look at that as well. 15 over 15. It has to be 15, right?
Yes.
Okay, now, get accustomed to this. If you write them in this order, then tan is what? 8 over 15. So if you write the sine and then the cosine, then you write the tangent. As long as these two are correct, then the tan will be what? 8 over 15. There it is. And then we'll take a look at a reason for that. The reason is very simple. The tan is equal to sine over cosine.
The other day when I went to class, because I had bio before, and the advanced students had the same, at the time when I came on board, I saw that they were for advanced students, and this is what I think we call tangent and
Okay, they have that.
and the board.
Yeah. And for the advanced, they have a lot of identities. One of them is sine squared plus cos squared is equal to 1.
Yes, sir. And then if I make it
Okay. You might not?
I might.
No, you make up your mind from now. Next week I did. Next week I did. No, you got it. You might just sound like next week because it's so many weeks away.
Sir, I will do it, sir.
I'm not so sure yet. We'll put that together. Yeah. So it's time to make up your mind here. Don't make up your face. What about B? Sine of B is what? B. We're going over here. Sine. Yes, it's right. 8 over 10 is right. Opposite over hypotenuse. Tan of B. Not tan. Let's go to cosine first. Cos of B is equal to what?
6 over 10.
6 over 10. And finally, as long as that's correct, tan of B is equal to what?
8 over 6.
Right. And that's correct is 8 over 6. What about C? Anybody finish C as yet? Let me make sure I'm those who I see recognize. Go on. Then I'm going to look at the C to try to train here. Come on, everybody wants me to tell you exercise, sorry.
Yes, sir.
So let's get with it. So we say that sine of C is, I'm looking right, it's right here. So C is sine is 48 over 50. That's correct. 48 over 50. What about cosine? 14 over 50. Let me make sure. Adjacent over hypotenuse. And tan.
48 over 14.
Yeah. As long as the first two are correct, then we may just write it down there because it is.
Sir, 15. 14 over 15.
14.
This one? Thank you very much. Any more? No. Okay, that's it. Correct. Now, students, when you're doing trigonometry, it is as easy as knowing the trig ratios. Knowing Pythagoras' theorem for the rectangle triangles, and then you're finished. When triangles are not right angles, we are going to take a look at what we do in a short while after this. So, here comes your favorite, Pythagoras' theorem. Pythagoras' theorem. What I'm not giving too much consideration to is that this is an audio visual that once it is created, you can go and watch it again. So I need to give consideration to that. Alright. Pythagoras' theorem. What did he say? Oh. He said if you have a rectangle triangle, that what? The square of the longest side is equal to this sum of the squares of the other two sides. That you'll realize later on that it is a certain modification of the cosine rule. H squared is equal to A squared plus b squared. So what is h equal to? Because we are making h the subject of the formula, which is squared. So we need to eliminate this square by taking the square root. Right. And we take the square root of both sides. Is that correct? Right. So when we take the square root of both sides, the square will be eliminated from this side. And then we'll have the square root of a squared plus b squared. Right. And it's as simple as making substitution into this expression. So I'm going to take my instructional manual and I'm going to check. Right. So we have 3 right angle triangles right there. Alright, somebody saying that that is easy.
Yes, sir.
So this is what? 9 centimeters, and this one is 12 centimeters. And you need to find the hypotenuse. I think that you all should just go straight ahead and find it before me because I'm going to go work that out right there and do the sentence. Not drawing to scale. Okay, I'm going to do this one. So for this one, the hypotenuse is equal to the square root of 12 squared plus 9 squared. The square root of square 12, what do we get? 144. Square 9, what do we get? When we put them together, we get what? Add them. We get 225. Is that correct? And what is the square root of 225? 15 centimeters. Right. That's all there is to it. And you're going to do that for the other two. Do it for this one. Don't worry, man. You'll soon get married. I'm speaking specifically to the one who is looking in outer space instead of just working the problem out, which is so simple. Then just the others and then a few seconds to work it out and you what they have to say. So what do we say? H is equal to the square root of 7.5 squared plus 4 squared, which is equal to the square root of square root of 31. What goes here? Square 7.5, what do you get? 56.25 plus 16. And when you add those, you get what? 70.25. Which I am sure you know the answer turns out to be just the same class. 8.5 centimeters. Real mathematicians don't give you answers that work out to be horrible.
Sir, I did something wrong, sir. Then I got an answer to 5.5 seat after go on.
You double this, you just put it twice this instead of squaring it. Yeah. Okay, so all of that is finished. So you're gonna have some more fun. Now, if irrespective of the short side that you want to find, then you know that the procedure will be the same as long as it's one of the short sides. Because you have your Pythagoras theorem which says that a squared is equal to a squared plus b squared. And if you want to find one of the shorter sides instead of the hypotenuse, say the hypotenuse is given, then you want to what? Transpose by saying a squared
Equals
minus anyone.
a squared
A squared
equal
b squared. So what is b equal to?
b is equal to
Square root
h
of
squared
The square root of
a.
h squared minus a squared. And you know that I do not accept anything written like this as a final answer. You have to put the proposed subject on the left hand side. H squared minus a squared. And that's how you are going to find the length of one of the shorter sides of the right angled triangle. It's just a matter of making a transposition. And the rule of thumb is that you're going to subtract rather than add. So we will put those triangles there, and by the time I'm through putting the triangles on the board, you'll have finished every single one of them because you have them in your instructional manuals. Do we have some right there? Yes.
Sir, I'm gonna go.
Repeat that?
Must go.
Yeah, do all the them. Although one is supposed to be done for you already. That's your first one. I'm going to call this, well, B is there, so we know what is B. This one, your favorite. 8 from is B. So you're going to find that. 7.5. I think it's meters in this case. One of the first one was meters. Anybody finish with any one of them as yet? Let's see what the first one says. A is equal to the square root of. What's that going to be? 6.5 squared minus 2.5 squared. Is that correct? Square 6.5, you get 42.25. And the other one now you get what? 6.25. And when you subtract, you get exactly 36. And the square root of 36 is what? 6. 6 meters. I'm not going to worry about any of the others until you are through. Let's go. You're finished this? You get careful down there, around. Let me put the answers there. Okay. 1, 2. And Louis, you know the girl to say 1, 3. And then I show up and those who are practicing problems from your yes, your tutorial. You are practicing problems from your tutorial.
Please.
Okay. You must get the money. Yes, you must get one. What you should try to do? Try to finish tutorial 1. And then by about the end of February, you take out tutorial 2 and try to finish it before the examination. You're not finish, but because I'm giving you too much work for you to finish. Because you know that I'm not going to give you too little work that you are through in Anglo-Latin saying that you don't have anything to do.
So if I were to think about the new license,
By the end of March, everybody should be finished with the syllabus.
Can't you see questions are in which one?
Tutorial 2.
Sir, I determined the kilos answer.
Then you know you made a mistake. Let me see that ridiculous answer that you said that there is that and how you are right. 0.
No, sir. No, sir. Gone. No, sir. Get gone.
short side. Let's be practical about it. Which one did you get the ridiculous answer for? This one?
Third one, sir.
This third one. What about this one? What did you get for this one?
Sir, I got 6 meters.
6 meters. For this one, I got. What did you get for this one? Alright, what I want you to work this one out before I go on the board.
Sir, I got 8.5 centimeters. 8.5 meters.
For which one?
Sir.
For this one,
Yes, sir.
I am sure you can get 8.5.
Oh, sir, I plus 4.
With that?
I plus 5.
Alright. Now, when you're applying anything in mathematics, try to be practical about it. Okay? Alright. Take a look at this now, Mr. You. Yes. What do you know about this side of a right angle triangle?
That is it. The longest part.
This is the longest side of a right angle triangle. Okay? You know that this is the longest side. So if you do this, B is equal to the square root of 8.5 squared plus 7.5 squared. Somebody please do this very quickly and tell me what you got. What you get.
Um, 72.25.
Try the square root of that.
16. Oh, to go from the sorry, what is it? 8.5 square root of 72.25. So you take away.
No, you're gonna add them. Add them and then find the square root.
The square root is
11 point? 3, 3, 6. Right. Now, mister, what do you know about this? In a right angle triangle.
So it's the hypotenuse.
Is the hypotenuse. What do you know about the hypotenuse?
Sir, it's the opposite of
It is opposite to the right angle. What else do you know about the hypotenuse?
the longest part.
It's the longest side. Look at this. So if this is the longest side and you get 11.33, then you are sure that you did not do something right. Okay?
Yes.
Alright. And you know what you didn't do right? Because we have a formula here. So what is it that you did not do right?
Sir, I
Right. But if you subtracted, I'm going to put in the final details for that. So the square root of, when you square 8.5, what do you get? Repeat that. Okay, 72.25. And when you square 7.5, what did you get? 56.25. 16, which is equal to 4 meters. Okay? I'm going to tell you to complete this one. Come on, mister. I need the answer for this one. Let me have a show of an abdo mentioned that before, they know that the students are going to pull the information. I don't want you to do that. So close your instruction and manuals and pay attention on the board. The first triangle we are going to solve. And please don't say it's a right angle triangle. You know it's a right angle triangle already. Yeah, right here. Thanks for monitoring the audio for me. There's a great chance that the one that you have in your book is going to look somewhat different from this. 10 centimeters for the hypotenuse. P and Q. It really should be capital R. Find all of the what? Missing what? Sides and angles. And when you are solving a right angle triangle or any triangle, try to find the easiest one first.
So R equals 60 degrees.
Okay, R is equal to 60 degrees. This is the easiest thing to find. We know that this is? 90. And this is? 30. So that makes this one? Right. So we know that R is equal to, I'm saying 60 degrees, 90 minus 30, which is equal to 60 degrees. So R is equal to 90 minus 30. That turns out to be 60 degrees. What do we find next?
R.
We just
Oh,
found
sir,
it.
I mean Q.
Q. Now students, in mathematics, any situation that exists that you can write one equation in one unknown, then your problem is fixed. Your problem is solved. You said minus from 180. Right, so that's acceptable. Right? But is this any less acceptable or is it correct? Yeah, because we are thinking that we have this angle that is 90 degrees. That means the other two must have a sum of 90 degrees. That's what we are saying. But if you said that all of the angles should add to give 180 degrees, then that's fine. In that case, you will have to what? Subtract the 90 and the 30, and then you will get. So it will be R is equal to 180 minus 90 minus 30. So that's going to be 180 minus 120, which is equal to 60 degrees. That's what you mean, right? Or what you could do is add these together and subtract it, right? Right. Any way you prefer. Now, as I said before, any situation that you can write one equation in one unknown to represent that circumstance, then the problem is solved. Understand what I'm saying? Right, so in this case, we're trying to find, did you say P or Q? Q. In this case that you're finding Q, as long as Q is the only unknown, then the problem is solved. Therefore, you have to target the knowns. So everything else has to be known. Right? Right. So if you're going to find Q, what you think you can use? Several things that you think you can use.
5 centimeters.
Where did you get that 5 centimeters? Take a good look at what you have on the board. Let me repeat that. You're going to use information that you have here to find Q. What are you going to use? What do we have in the right angle triangle there that you can use in order to find Q?
60 degrees and 90 degrees.
You can use it 60 degrees.
And then 90 degrees.
We won't be focusing too much on the 90 degrees. The 60 degrees, what else? The 10 centimeters. Anything else? The 30 degrees. Okay? Alright. Should we use the 30 degrees or the 60 degrees, or it does not matter?
Doesn't matter.
60.
Read that? The 30. Why you say 30? Alright, let me tell you why I have used 30. Students, in any situation in which you can use a given value rather than a previously calculated value, use the given value that rather than the one that you have calculated. Okay? So this one was calculated. It is correct. But I'm giving you ideas that you can use in the future. You have some cases in which you have to use a previously calculated value. But there are some that you can avoid it. And this one we can avoid it. So just avoid using a value that was previously calculated. Use the given value. So we're going to use what then? And the 30. 30 is an angle here. And what do you say about Q? It is opposite to the 30 degrees angle. And which other side is given?
The 10.
10 is it? Hypotenuse. So you have what? The opposite? No, wait. We don't have it, but it is involved in your equation. We are talking about the opposite and the hypotenuse. Yes. You get it fast, man. So it's sine, right? Sine is? Because you cannot just say sine. But you have to say sine and also say that what? Sine is opposite over hypotenuse. Right. Now how do we write that? We say opposite. I'm going to change this slide. We say opposite over hypotenuse is equal to sine. Sine of which angle? 30 degrees. Now you have what? One equation with one unknown. That's just straightforward. So we say what? Q is equal to 10. We are dividing by 10 here. So we will eliminate the 10 by multiplication. It is equal to 10 times 0.5. As your sine 30 is 0.5, correct? So that will give you what?
5
5 what?
centimeters.
Centimeters. And what else is there for us to find? P. So what are you going to say for that P? P, well, you're still going to the knowns that we have here. So if so be the case, relative to this angle, P is what? Adjacent. And we said that this known here is what? What trig ratio contains adjacent and hypotenuse? And cosine is equal to what? Right. Because although you identify the trig ratio as adjacent, that is still not in. Sorry, not adjacent. Cosine, that's still not enough. You could use Pythagoras theorem, but you would have to use the sine that was previously calculated. Your result will not be wrong. But if you adhere to that principle, then you will make less mistakes. And if you make a mistake, somewhat like that, you shouldn't really lose mark in the examination. Because the examiner will not penalize you they will not penalize you for an error that is a direct consequence of making a previous error. So you should not lose any mark there.
As in, if you're calculating this, but it's incorrect, but they use the Pythagoras theorem, so the formula would be correct for the answer.
Right, yes. And if that happens, the examiner should not penalize you for that. What the examiner should really penalize you for is the incorrect answer that you got first. the other part of the problem, then you should not lose any further mark. Right? So the examiner does not penalize you for what we call cascading error. A cascading error is just an error that is the result of making a previous error. You should not be penalized for that error like that. So we're saying what? Cosine P over 10 is equal to cosine of 30, is that right? And we're dividing by 10, so P is equal to what? 10 cos 30. 0.866. That's right? So P is equal to 8.66 centimeters. And we are through with that one. Another one. We will come across circumstances in which you will have to use a previously calculated value. Say this is 40 degrees. This is 80 centimeters. And I don't think that there's anything else in that triangle except a right angle. And we're going to solve that right angle triangle. And of course, by solving the right angle triangle, what do? Find all the missing sides and angles. Find all of the missing sides and angles. Which one is the easiest one to find first? A.
So then A equal 50 degrees.
So, A is the easiest thing to find. So we say what? A is equal to
90 degrees subtract
90 minus 40, which is equal to 50 degrees. What do we find next? C. Alright, let's say we find C. Now, if we're about to find C, what will we use? The information that we have there.
We use 40 degrees.
We use 40 degrees and 18 centimeters. 40 degrees, 18 centimeters. That's what we will use. 40 degrees, 18 centimeters. Now, what do you say about this C? It is adjacent to the 40 degrees angle. Adjacent. And the side that we are using is what? Opposite. So, yes, opposite to the 40. So we are about to use to find the adjacent, and we have the opposite. So what trig ratio is that? Adjacent and opposite. Trig ratio is tangent. And tan is equal to what? Right. Do not forget that you also need to say what it is actually equal to. Right. So, look at this. Tan of 40 degrees is equal to what? Opposite over adjacent. So we say tan 40 is equal to opposite over adjacent. Now students, this might be something that you probably don't want to store in your brain. Right? But what I do is, look at this one. The unknown. The unknown is in the numerator. When the unknown is in the numerator, I put it on the left hand side. So you just do this. One transposition, and you have right here, okay? When it is in the denominator, I want to put it on the right on this side, you will not have to switch the equation around. Because when you multiply like this C there, so we say what? C tan 40 is equal to 18. That's correct? So it is on the left hand side now. So what is C equal to? How do we eliminate this tan 40? By dividing. 0.833.
Yes, sir, that's 840.
Yes. Look at this now. Don't do the calculation in it. 833.
Yes, sir.
Okay. Alright. Don't do that calculation I said. Look at this now. This is what? Number? 18. In order to make a calculation, Mackenzie, this number is close to what number that will give you a quick calculation? 0.8. Look at 18. Which number is this close to? 8 what? 839. Okay, nice. 839. Alright. So what number is this number close to in order that you might do a quick calculation? Repeat that? 9. Actually 0.9. Correct? 9 into 18. So if it's 0.9, then it sure is 20. Correct? Okay. But notice that this is somewhat less than 0.9. So if you divide it by a number that is less, you should get more. So I am looking at 21, 22, or 23. What is the correct answer?
20.
21 point? 21.45. Alright. So this is equal to, so C is equal to 21 point, how do I say 21 centimeters? It will not hurt. Because this is not an exercise in accuracy. This is an exercise in applying the trig equations. Yes, the trigonometry. Alright. So now that we have found C, what's the next thing that we need to find? B. Okay. B is the hypotenuse, and the known side is opposite to the known angle. So this is opposite and this is hypotenuse. What trig ratio is that? Sine. Now, sine is equal to what? Opposite over hypotenuse. Opposite over hypotenuse. So this is going to go in the denominator. So you put it on the right hand side. So sine 40 is equal to opposite over hypotenuse. Now what do we do with this b that we are dividing by here? So b sine 40 is equal to 18. So b is equal to 18 over sine 40. 0.64. No, not that. I don't know. I know the most popular ones. Alright, look at this now. Which number is this close to that will give you an approximation? If this is 18. It's close to 6, right? And 6 into 18 is what?
3.
So it is supposed to be close to 30, correct? Because it's 0.6. But no, this is larger than 0.6. So your answer should be less than 30. So you can look at that. 29, 28.
28, sir.
Okay. So this is equal to what? 28 centimeters. And so when you're solving problems, don't lock your mind out of it and just be focusing on the digits that the calculator gives to you. Make sure that you are making an approximation. That's what I do all the time, so I can tell when I'm making a mistake. If I have a horrible answer way out from 28, then I know that I would have made a mistake. And you will learn, if you are interested, when you see a trigonometry problem on the CXE examination, just to take a look at it and be able to tell very close to what all the answers are. sometimes you will be precise, sometimes you are going to be exact. So if you are serious, then we'll get to that point that you can really have a very good idea of what the answer is, even before you work problem out. Now we're going to look at the last triangle that we are going to be solving.
For today, sir.
No, you know it's not for today. Listen, you know Sunday class don't come to class every Sunday, right? You want the Sundays off? Then the Sundays that you are here, you need to work hard. Yes, because we have a JTA meeting to attend. So, repeat that. Yeah, nothing. 12 centimeters, 13 centimeters, y, x, w, and your right angle. Come on, students, and what are you going to find first? Y.
X.
What is y equal to? The square root of, if somebody starting out by saying the square root of what? 13. That's 12 centimeters. Yeah, 12 square. Now, students, I don't think that the CXC examiners will put a problem like this just to catch you. But some students, as soon as they look and see that two sides of a right angle triangle are already given, then what they do is invariably add. And then they get an answer that is larger than the hypotenuse, and they do not recognize that. So, make a difference between when you are finding the hypotenuse as opposed to when you are finding what? The length of one of the shorter sides. No problem with this one, the square root of 169 minus 144. When you subtract them, all you get is
125.
you get the 75, and that is going to be what? 5 what? Centimeters. Okay. Anything else that we can find? What is that? X. X. What are you going to use to find X? You have to use what? I didn't hear that. Right. So you're going to find X. What are you going to use to find X? The other two, the two sides that are given. By saying what? For the side argument, this is what? Opposite to this, the argument that you're attempting to find. Right, it's opposite to the X. And this one is what? Adjacent, yes, it's adjacent. But what is the special name given to that adjacent side? The hypotenuse. Right, because when you go to school and you say the adjacent, you might be ridiculed or told that you are wrong. But it's actually adjacent to the angle. But it is actually the hypotenuse. Yes. So we say what? Sine. Is it opposite over opposite sine? Sine of x is equal to 12 over 30. So sine of x is equal to 0.9 something. 2. Thank you very much. Alright, listen now, students. Look at this easy. What is 9 over 10? 90%. That's that. 9 over 10 is what? Actually 0.9, right? No, students. Look at this one. 11 over 10. Let's put it the other way. It's actually means it's supposed to be 0.9 something, which is larger. 10 over 11 or 11 over 12.
11 over 12.
Which one is larger? 11 over 12 or 12 over 13?
12 over 13.
12 over 13. Alright. If so be the case, this is 9 over 10, which is 0.9. So we imagine that 12 over 13 must be more than 0.9. So it's supposed to be 0.9 something. Understand that?
Yes.
Right. As soon as you get to 9 over 10, and that is 0.9, then this should be a little bit greater all the time. So I'm sure that it's actually 0.9 something. So what do you get? Oh, sine of x is equal to 0.92. So x, because what you have here is the sine of the angle, and you need to find the angle. So you have to do the reverse of taking the sine, which is of course what? Taking the sine inverse of the figure. So x is equal to sine inverse 0.92. What do you get? That's equal to 67 degrees, say, right? So, in the long run, when we are doing the tutorials, you will learn that one of the popular right angle triangle is your 5, 12, 13 triangle, which is this one. And you should know this, the angles in that triangle. 67, 23. Yes? Alright, so which is sine? So this is like sine 0.92 equals. It has to be in P because you're working in degrees of time. Now, what about the other angle? Don't use a previously calculated value. You're going to still use these two numbers. So you're going to say what? For this one, you're going to say the other way around. Adjacent over hypotenuse, right? So, cos of W is equal to the same thing, 12 over 13. We know that we could just subtract this from 90 and get this, right? So cos W is equal to this. So cos W is equal to 0.92. So W is equal to cos inverse of 0.92, which is equal to 23 degrees. Okay? Right. I'm going to take a few seconds to take a deep breath, and then we'll return to another topic. Right. You will want to return when everybody else is staying at home, right? Don't worry.